video, we're going to be showing you how to complete the square.
To understand the basics of this video, you need to understand the link between these two lines when squaring a binomial. Half the middle term in the bottom line is equal to the constant in the binomial, and the constant in the binomial squared is equal to the last term.
Our first example is x squared minus 4x minus 10 equals 0, and we have to convert this to the form a bracket x plus h bracket squared plus k equals 0. So we start by moving the constant over. We do this by adding 10. We then have to find half of minus 4, which is minus 2, and we then square minus 2 to get 4. We then add 4 to both sides, and then we can convert this into x minus 2 squared equals 14. We then move the constant back over by minusing 14. And we end up with x minus 2 squared minus 14 equals 0. Which, as you can see, is in our form a bracket x plus h squared plus k equals 0. Now use this to find our points on the graph. So we start by moving the constant back over by adding 14. We then must remove the square. So to do this, we square root both sides. We then end up with x minus 2 equals plus minus square root 14. To then finally get x on its own, we add 2 to both sides, and we end up with x equals plus minus 14 plus 2. Then our 2 points are x equals root 14 plus 2, which is 5.74. Or minus root 14 plus 2, which is minus 1.74. Just to recap the steps, step 1 is to ensure that the coefficient on the x squared is 1. The second step is to bring the constant over to the other side of the equation. The third step is to divide the x term by 2, then square and add to both sides. And the fourth step is to rewrite in the correct format.
The first thing I did was divide the equation by 2. This gave me x squared plus a half x minus 6 over 2 equals to 0. This simplified to minus 3. I then plus 3 to both sides of my equation. This gave me x squared plus a half x equals to 3. In my rough work, I halved the coefficient of the middle term. This gave me a quarter. I then squared the result, which gave me 1/16. This is the number I added to both sides of my equation. I then put the quarter into the bracket, so it gave me x plus a quarter squared equals to 48 over 16 plus 1/16. This then simplified to x plus a quarter squared equals to 49 over 16. I then minus 49 over 16 on both sides to bring everything back onto the left hand side. This left me with x plus a quarter squared plus 49 over 16. I then made sure to multiply the 2 that we divided at the beginning, so I was left with 2x plus a quarter squared minus 49 over 8. To solve for x, I divided both sides by 2. I was then left with x plus a quarter squared minus 49 over 8. I added 49 over 16 to both sides to bring it to the right hand side. I was then left with x plus a quarter squared equals to 49 over 16. I square rooted both sides to get rid of the square. I was left with x plus a quarter equals to plus or minus square root of 49 over 16. I minus a quarter on both sides, and I was left with x equals plus or minus 7 over 4 minus a quarter. For the positive answer, I was left with x equals to 1.5, and for the negative answer, I was left with x equals to 2. If you look back at the answer, you can see that it is in the form ax plus h squared plus k equals to 0.
Now we are going to look at an exam question example in which we have to complete the square. We are given the equation 2x squared minus 7x minus 10 is equal to 0. And the first step in completing the square is to divide by 2, which is the x squared coefficient. That leaves us with x squared minus 7 over 2x minus 5 is equal to 0. And then we have to add 5 to both hand sides of the equation to get the constant over to the right hand side, which leaves us with x squared minus 7 over 2x is equal to 5. Then in our rough work column, we're going to half the x coefficient, which is minus 7 over 2, to get minus 7 over 4, and then we're going to square that to get 49 over 16. We will then add this onto both sides of our equation, leaving us with x squared minus 7 over 2x plus 49 over 16 is equal to 129 over 16. Then on the left hand side of our equation, we can use our binomial factorization to get x minus 7 over 4 all squared is equal to 129 over 16. Then we have to take away 129 over 16 from both sides, and that leaves us with x minus 7 over 4 all squared minus 129 is equal to 0. Then our last step is to multiply by 2, because 2 was our original x squared coefficient, to get 2 by x minus 7 over 4 all squared minus 129 over 8 is equal to 0. We now have it in the form a by x plus h all squared plus k is equal to 0, and from this we can see that our minimum point on the graph is 7 over 4 minus 129 over 8. Now we have to move on to solving the equation to get the two roots on the graph. So our first step is to move the constant over to the right hand side again. So we do this by adding 129 over 8 to both sides of the equation, leaving us with 2 by x minus 7 over 4 all squared is equal to 129 over 8. Then we have to divide by 2 on both sides, leaving us with x minus 7 over 4 all squared is equal to 129 over 16. Once we square root this, we are left with x minus 7 over 4 is equal to plus or minus the square root of 129 over 16. When we add 7 over 4 onto both sides of the equation, we are left with x is equal to plus or minus square root of 129 over 4 plus 7 over 4. When we simplify this, we are given two roots, one which is 4.59 and one which is minus 1.09.
What Connor found when solving this equation was the two roots where the graph cuts the x-axis as well as the turning point of the graph, otherwise known as the max-min point. From this, we can draw a rough sketch of the graph, or using a table, we can solve the graph to find more points.